Alright, so we're solving triangles, finding all of the missing parts. We want to watch out for those side-side angle situations. Those ones where you might get two triangles or no triangles at all. So I start off and I don't really care about labeling it or drawing my triangle to scale. And this first one is one where you have to watch out for the side-side angle situation. So watch out. Because this is the one where you might get more than one triangle. So we've got a full ratio, so let's find angle B first. Sine of B over 11 equals sine of 73 over 18. And again, you can't use sine or cosine on something like this because we don't have a hypotenuse. So I'm going to multiply this by 11, multiply this by 11, and you get sine of B is 11 times the sine of 73 degrees over 18. The sine of B equals 0.5844, and again keep the decimals in there. We're going to do inverse sine. Inverse sine of 0.5844, which gives us 35.8 degrees. So that's angle B. Now 35.8, we want to try for our second angle, and so what I mean by that is sine of 35.8 works that way, but the angle that is 180 minus 35.8, 180 minus 35.8 is 144.2, is the second angle for B. That doesn't work, because if you add 144 plus 73, doesn't work, because we've run out of degrees. So 180 minus our 73 minus our 35.8, 180 minus 73 minus 35.8 is 71.2 degrees. So that's angle C. And we've got our angle B. And now let's find side C by using the same ratio we did before. But I'm going to flip it over. I'm going to make C over 71.2, and I need the sine of the angle, equals 18 over the sine of 73. And I flip it over because of strictly convenience. Now I only have to multiply by the sine of 71.2. Multiply by the sine of 71.2. And so C is 18 times the sine of 71.2 over the sine of 73. And so I'm just typing that in like this, and we get 17.8. And so that's side C. We've got angle C, side C, angle B, and there's our first triangle solved. Moving on. Next triangle. A, B, C. 103. B is 15, and C is 24. So because we don't have an angle and a side matchup, we know we're going to use law of cosines. So I'm going to start with finding a. So a squared is equal to, and so 24 squared plus 15 squared. It doesn't matter what order you put those in because you're just adding them. Make sure that you just type this all in at the same time. In other words, sometimes people group this and like to do all the numbers first and then multiply by cosine, but it doesn't work. So 24 squared minus 2 times 20. So we're typing this in, 962, and so that's the a squared. Don't forget to take the square root of it. And I'm just going to use second answer, second square root, and then second, and hit the negative button. So 31.0. 31.0 is a side, and that's A, 31.0. Now, if we hadn't already gotten our obtuse angle, you go to use the law of sines to find the other parts, you would want to find the smallest angle first, simply because the other one might be have the chance to be obtuse, and law of sines, inverse sine wouldn't tell you that. So sine B over 15 and sine 103 over 31.0. Sine B is equal to 15 times the sine of 103 over 31. 15 times the sine of 103 over 31. 0.4715. And so then the inverse sine of 0.4715 gives you an angle B of inverse sine, second sine, and use the answer again. And you got 28.1. So we've got angle A is 28.1 degrees. And if we subtract 180 minus 103 minus 28.1, we get our angle C. 180 minus 103. We get 48.9. And there's angle C. And we got side A before as well, and that was 31. Alright, next triangle. Sorry, I was writing a little off the screen. Next triangle. ABC, B is 21, B is 17, and C is 32. So again, we have a side-side angle situation, and you want to watch out. 2 triangles possible, maybe. You can bet that the last one we didn't have it, we will probably have it this time. So, law of sines, because we have the complete ratio. So sine of C over 32 equals sine of 21 over 17. Those and those. Match them straight up. So multiply by this 32 over 32 times the sine of 21 over 17. Multiply by 32, multiply by 32. 32 times the sine of 21 over 17. Sine of C is 0.6746, and so on. So inverse sine, angle C is going to give us the inverse sine of 0.6746 equals 42.4 degrees. So angle C is 42.4. 180 minus our 21. I'm sorry, 42.4. 180 minus our 42.4 is going to give us a possible second angle. 42.4, because the sine of 40s and the sine of whatever this angle is over here, 180 minus that, is 137.6. The sines are the same. The y values are the same because they've gone up the same. So I'm going to make two columns over here. And we're going to have angle C can either be 42.4 degrees or angle C can be 137.6. And so then angle A, that leaves angle A to be the leftovers, the remnants, 180 minus 21 minus 42.4, and so that's angle A, 116.6. And the other angle A to be 180 minus 21 minus the 137.6. Because all triangles have to add up to 180. So there's our second angle. And now to find side A. So we're going to use A. The side A is across from the sine of 116.6. And set it equal to our original 32. And actually I'm going to use 17 because there's no rounding in that one. 17 over sine of 21. And that's our one triangle. We'll solve that one. And then do it in the same way, but with our other angle A. 21.4. 17 over the sine of 21. So A, if you multiply the sine over, 17 times the sine of 116.6 over the sine of 21, and 17 times the sine of 21.4, sine of 21. So we're going to do this. 17 times the sine, 116.6, divided by the sine of 21. So we get A can be 42.4, or A can be, and I'm going to hit the second answer and use my 21.4 in there, or 17.3. And so if the biggest angle is across from A, that means the A will be the longest side. If C is the biggest angle, C will have the biggest side, which was 32. So there you have it. Triangle 1, triangle 2.